So this is now you bothered about the sign of that. Okay, sign में क्या होते हैं? So I have 1, 2, 3. That's the order. So always take this as the order. 1, 2, 3. 1, 2, 3. इसका permutation लेने का always. Okay. So what I find is that 1, 2, 3. This is always 1. Epsilon 1, 2, 3 is 1. So this is nothing but A11, A22, and A33. Now 1, 3, 2. So 1, 3, 2. 1, 2, 3 के लिए क्या करने का? ये एक को इंटरचेंज करो. So 1, 2, 3 आ गया. So only one permutation. Sorry, odd permutation. So this will become minus. A11, A23, A32. A32. Now here you see 2, 1, 3. So one permutation, odd permutation. So 2, 1 को 1, 2 करो. So एक ही बार करने का. So 1, 2, 3 I will get. So that's again minus. So A12, A21, A33. 2, 3, 1. Okay, so 2, 3, 1. So what one has to do? 2, 3, 1. So I have to make first 3, 1. So from that I will get 1, 3 and 2, 1 again or ek bar. So if you want to do it 2 times, then I will get the 1, 2, 3. Okay, so first 3 and 1 interchange. So I get 2, 1, 3. Then 1 and 2 you interchange. So I'll get 1, 2, 3. So here 2 is needed so that it will be again plus. Plus A12, A23, A31. And what about here? This is this plus. Here I have 3 and 1. So 1, 3 आएगा. Then 3 and 2, 2, 3 आएगा. So 2 बार again plus. A13, A21, A32. 3, 1, 2. Okay, so what you can do here is what is those permutation? You have a 3, 2. So first I can make 2 and 1. So 3, 1, 2 आएगा. Okay, then you can make 3 and this one. So 1, 3, 2 आएगा. Then our एक बार 1, 2, 3 आएगा. So 3 times. So it is minus. Okay, A13, A22, and A31. Okay. Now look for
sir.
This.
सर ये 3 बार किया है उसके अच्छा तो ऐसा है ना कि हम 3 और 1 को कर सकते हैं ना इंटरचेंज.
Yes. Only then also order kind of thing. है ना? Order तो minus ही आएगा. So now.
Yes sir, पर एक बार ही.
Yeah. So now you look to this one. आपका these values. I cannot show it both here. Now you check this 1, this 3, and then this 4. 3 and 4 and see, confirm that they are equal. 3 and 4. What do you find? You just make a check and tell me whether they are equal or not.
Yes sir, they are equal.
They are equal. Okay, so I write that from 3 and 4 we get this A11, A12, A13, A21, A22, A23, A31, A32, A33. So that is equal to epsilon ijk, A1i, A2j, A3. Okay, so determinant I can use it using a very compact and simple expression. Okay, so now the thing, I, yeah. So my aim is to teach you the tensor calculus, tensor analysis, so in the tensor analysis later you will see that the suffixes and superscripts are important thing. So I want to make everything in terms of that. Okay, so that you will understand why I need to do this. When I start the tensor definition and kind of thing, you will understand. Okay, so that is the purpose. That's the purpose. That's why. Otherwise, there is no need of doing all these kind of things. Okay. Now, similarly, we can show that the same determinant. This is equal to epsilon ijk a I1 a J2 and a K3. Okay, the same thing you write it here. Now the important thing comes. The study of tensors is important when there is a coordinate transformation, one coordinate system to another coordinate system. So, the basis is it's interest of all students of chemistry, mathematics, or physics. Einstein discovered the theory of relativity. So there is initially the Newtonian law. Okay, then from Newtonian law, one has to go to special theory of relativity. Then one has to go to general theory of relativity. And in the general theory of relativity, the physical laws should be same in all coordinate system. That is what it says. Physical laws should have the same form. For example, Newton's law Newton's law of motion is valid only in inertial frame. Inertial frame means all frames of reference which are moving with a constant speed. If you consider the F equal to ma, Newton's second law of motion in a stationary coordinate system x, y, z, and there is another coordinate system which is moving with some acceleration, or a coordinate system which is rotating. F equal to ma I will get in this, but I will not get F equal to ma form in the other coordinate system. So that is the difficulty. When you change coordinate system, the nature of the physical law changes. Einstein told that all physical law should be same in all inertial coordinate system. Whatever physical law is there, it should not change by coordinate transformation. Okay, so people were searching for quantities. Einstein actually searched for quantities which is not changing by coordinate transformation. Then he discovered the tensors. Okay, so my aim is to come to that. Okay, so the basic idea here is the coordinate transformation. Okay, one coordinate system, how you can go to another coordinate system. Then the physical law should not change. So you have to, that is why all physical quantities you are writing in the tensor form, so that coordinate transformation will not change the nature of the law. So that's the idea. So let me talk about what is the coordinate transformation. Okay, the meaning, transformation, linear transformation, etc. You have seen many transformation. So here I talk about a general kind of transformation. So next side heading is coordinate transformations. Okay. Now suppose you consider a vector. Okay, a vector v bar. So I take a vector in Rn in the n-dimensional space. This we denote it by maybe denoted by x1, x2, etc. xn. Okay, I am writing this way, but usually in your linear algebra, you have studied it in another way. You are writing v bar is equal to x1, x2, etc. xn. This is a subscript x1, x2. Okay, this is the usual way of representing it. Now in the tensor analysis, we are using a different kind of notation. Instead of the suffix, I am writing superscript. x2 doesn't mean that x square. Don't think that. X into x nahi hai. X raised to n means it is not a x into n times. It is only a kind of notation. Okay, so this is the second component. This is the nth component. That is the meaning. Now, why we make such a kind of new notation is because many of the things will be easy if you make this kind of notation. Okay, so I tell you that whenever you use this kind of notation, don't think that these are the powers. They are index. It will represent index, the position. Okay, and if you use in some examples, then you will understand that by practice you will understand that the actual meaning of that. Okay, so remember that I am representing a vector v bar in this form rather than our old method of doing in this way. Okay, so thus the familiar way of representing okay, representing v bar is equal to x1, x2, etc. xn by subscripts are now replaced by superscripts. So if we write x square whole cube, it means the cube of the second component of the vector v bar. Okay, so otherwise what is it? X square whole cube, according to the law of exponents, it is x raised to 6. Okay, don't think that it is x raised to 6. It is the second component ka cube. So that meaning is to be taken. Okay. Now you have many coordinate systems you have seen. You know different kind of coordinate system. From one coordinate system, how will you go to another coordinate system? Say, for example, the most familiar coordinate system is our rectangular coordinate system. Rectangular coordinate system. Okay. So Newton's laws are mainly developed in this coordinate system. So what is a rectangular coordinate system? A coordinate system xi. A coordinate system xi. When I say coordinate system xi, which means first coordinate is x1, second coordinate is x2, third coordinate is x3. If there are n dimensions, then I will have x1, x2, etc. xn with the superscripts. Okay, so this is a rectangular is a rectangular coordinate system, rectangular coordinate system, coordinate system, if the distance, between 2 points, between 2 points, first let me take the point P, so I call it as x1, x2, etc., xn. Okay, and another point, let me call in the n dimension q, let me call it as y1, y2, etc., yn, is given by in the rectangular coordinate system, the distance pq is given by the distance formula. What is that distance formula? It is square root of x1 minus y1 whole square plus x2 minus y2 whole square plus etc. xn minus yn whole square. Okay, so this I may put it as in short notation. This is square root of delta ij, delta xi, delta xj, delta xi, delta xj. What is where delta xi is equal to xi minus yi. Okay, now you familiarize with the notation. See, I am doing the simple things to make you to familiarize with the notations, the new notation. So when I take this delta xi, delta xi, delta xj, what does it mean? According to this definition, this is your Kronecker delta ij, delta xi क्या है? xi minus yi. Okay, this into delta xj क्या होगा? xj minus yj. Now you know this is something which you can say by Einstein summation convention. ये क्या होगा? I is repeating and j is repeating. So this is nothing but this is equal to आपका जो margin में ये लिखो आप delta 11, okay, into x1 minus y1 into the same thing, x1 minus y1. Both I and j I am taking 1. Suppose I take I equal to 1 and j equal to 2, क्या होगा? Delta 1 2 is 0. So when they are equal, then only you will get value. So in n dimension, this is nothing but delta 1 1 into this, delta 2 2 into x2 minus y2 into x2 minus y2 plus etc. delta nn xn minus yn into xn minus yn. Okay, now delta 1 1. So what is this? This is nothing but x1 minus y1 whole square. This is same thing. Plus x2 minus y2 whole square plus etc. plus xn minus yn whole square. Okay, which is precisely this. आप ये देखो, this one. This is precisely this. So I can write by using this short notation. Okay, so this is the meaning of this one. I think you understood the thing. Okay. So now, hence, all coordinate systems x bar I defined by x bar I is equal to AIR XR, where Aij, this is a matrix, is such that ARI ARJ, this is equal to delta Ij, is they are rectangular, are rectangular. Okay, so this is a transformation. I am initially in this coordinate system. Okay, which coordinate system? Xi coordinate system. Now I am going to x bar I coordinate system. So xi2. So this is one rectangular coordinate system. This is another rectangular coordinate system. In what way it is transforming? It is transforming like this. Like this. So when I say the transformation is like this, you must understand that x bar 1 is equal to, what is that? A11 x1 plus A12 x2 plus etc. A1n x. So this is the transformation law. Up idhar dekho, R is repeating. So Einstein summation convention. So that summation will be over that one. Similarly, second coordinate x bar 2 will be accordingly you change. So from this xi coordinate system, this is xi coordinate system on the right side. Here x bar coordinate system on the left side. This is the way by which you can go from one coordinate system to another coordinate system. And what is the transformation law? The transformation law is ARI plus ARJ is equal to delta Ij, which means that only diagonal entries will exist. All the other entries will become 0. Okay, then such a coordinate system is called rectangular coordinate system. Okay, in which the distance between 2 points will be always in this particular form. Okay, so that is our usual.
Sir, in this notation, distance notation.
Okay. So here what happens is AI and AJ, they are coming as subscript. Am I right? So that is why this notation is AIJ is coming here. Okay, so this is essentially iska notation ka meaning kya hai, I will tell you. This is a matrix and this is another matrix. When you multiply that matrix, you will get a unit matrix. This is the meaning that I am going to explain it afterwards. Okay, so this represents an element of a matrix. This is an element of a matrix. When I multiply, either I will get 1 or I will get 0. If I equal to j, I will get 1. If I is not equal to j, I will get 0. So that means that I equal to j means all the diagonal entries are 1. All the other elements are 0. What does it mean? It means that you are getting a unit matrix. Okay, so this idea may be a little difficult for you now, but I am going to do that later. Okay, so this is a transformation, one coordinate to another. It's a linear transformation. This is merely a linear transformation. Okay, so rectangular coordinate system. Now there is another thing. There is what is called curvilinear coordinates. Okay, so there is another coordinate system called curvy. You will study this in the first unit also. Okay, I am there. You will study in detail. But here I am also taking curvilinear coordinate system. Curvilinear coordinate system. Coordinate system. Okay, so this is something which you cannot imagine now. See, what is our usual way of doing it? You will take an x-axis. Okay, you take an x-axis. Something like this. So you have an x-axis like this, and you have a y-axis. Okay, something like you take a y-axis. So this you may call it as a rectangular coordinate system. So I have an x-axis and I have a y-axis, and they are perpendicular to each other. You call it as a rectangular orthogonal coordinate system. Okay, so that is why precisely this coordinate system, I have considered these quantities in this coordinate system. Now, can you imagine that you are here? I have an x-axis. X-axis is a straight line. You know, but straight line is a special case of a curve. Straight line is a special case of a curve. Okay, y-axis is also a straight line. So it is a special case of a curve. Now can you go in a more detail, general kind of thing? So that means, suppose, can you consider your x-axis itself is something which you can consider. Suppose your x-axis is something like this. So I am considering a curve. X-axis is a curve. Okay, and in the same way, I am assuming that my y-axis is also some curve. So something like this. Okay, so my x-axis is a curve. Then I have an equation y is equal to f of x, and my y-axis is y is equal to g of x. And suppose I want a point here. In the rectangular Cartesian coordinate system, I have x and y. In this coordinate system, rectangular Cartesian coordinate system. Now, what about in this curvilinear coordinate system? I should represent my x and y as some functions here. Okay, so that is as well valid. Okay, I am looking to this point based on this.
सर कुछ लोग लॉबी में वेट कर रहे हैं, बेड नेटवर्क की वजह से उनका कॉल ड्रॉप हो गया है ना, तो वो लोग लॉबी में है.
Okay. So this is the meaning of curvilinear coordinate system. The coordinates itself are curves. Okay, so how can you do this? In this case, what will be the nature of different quantities? That is what we are looking for now. So curvilinear coordinates. So suppose that in some region of Rn, two coordinate systems are defined. Two coordinate systems are defined. Okay, are defined. And suppose that these two coordinate systems, are connected by equations of the form x bar I is equal to x bar I, x1, x2, etc., xn, 1 less than or equal to I, less than or equal to n. Okay. So this xi bar, it is a function of. So that is what I am saying. Here y is a function of x. X means this x coordinate. or you can see that this itself is a relation connecting x and y. This is also a relation connecting x and y, where x and y are rectangular coordinates, that way. So it is a more general kind of thing. Okay, if xi are ordinary rectangular coordinates, then x bar I are called curvilinear coordinates. If the transformation is not linear. Transformation is not linear. Okay, you understood what's the meaning of the transformation is not linear. See, for example, let me take x bar 1 is equal to 2x1 plus 3x2. ये transformation आप देखो. Now let me consider another transformation. X bar 1 is equal to 2x bar x dash square x1 square plus x1 x2. आप ये दोनों transformation का difference देखो. Either it is linear, 2 into x1, 3 into x2, x square nahi, it is x2. So this is a linear transformation. Okay, but when you look to this one, 2x1 square, this is x1, x2, so this is non-linear. Okay, so but the coordinates are rectangular coordinates. So when you look to this coordinate system and this coordinate system, they are different. Here it is linear, here it is not linear. A transformation of this form, you are going from one coordinate system to another coordinate system, which is of this nature. So then we call it as a curvilinear coordinate system. So curvilinear coordinate system means of this type, not this type. Okay, now in this case, x bar I, they are called affine coordinates. The name given to it is affine coordinates. Now let me show you some examples of, then you will understand this idea. These all things you have studied it actually. Okay, what is this curvilinear coordinate systems? Okay. So the three most common curvilinear coordinate system. Curvilinear coordinate systems are given below. Okay, three most common. So first one is, it is the polar coordinates. Okay, so what is a polar coordinate? Okay, so here for polar coordinate you have first I will show you the connection between them. Okay, so I have this coordinates. This is a rectangular, this is the vertical line. Okay, and again I have the horizontal line. I have this. Okay, then I may have so let me put it like this. I take a point somewhere. This, okay? And let me put it. Okay, let it go. So here, this is my x-axis. This is my y-axis. And then this is the rectangular coordinate system. My coordinates are x and y, x, y, and y. But now, if you take this angle between them, suppose this angle is theta, and this length is r, okay, then the same point, let me call this P, I represent it by r theta. Okay, while the rectangular coordinates, I call it as xy. What is x? This is my x, this is my y, and this is my x, and this is the origin. See, two coordinate systems I have shown it in a single figure. Okay, one coordinate system is a rectangular coordinate system, another is the polar coordinate system. For polar coordinate system, what I needed is I need a horizontal line, what is called the initial line, and I need an angle. Two things are needed, distance and angle. Here both are distances. Okay, and here what I do is that I use the new notation. Okay, so here what is polar coordinate? Let x1, x2, xy ke jagah I am writing x1, x2. Okay, this is let me have with a bar, x1 bar, x2 bar. So this I call it as the coordinate system xy, and x1, x2, this I call it as r theta. So I have a two coordinate system, one x bar, y bar, x bar 1, x bar 2, I call it as xy, rectangular coordinate system. x1, x2, this is another coordinate. What is that coordinate system? R and theta. Okay, with r greater than 0, distance. So this I always take greater than 0. Then you know that you have studied x is equal to r cos theta and y is equal to r sin theta. Okay, so this is a curvilinear coordinate system transformation. So what is the reason? Either r is there, theta is there, is a multiplication is there, so it is not a linear one, this transformation. So that is why this is a curvilinear coordinate system. Okay, so this is what's time? So we have 5 more minutes. Okay. Then the transformation I can write, then how these coordinates are related, that's the thing. Then x1 is equal to, x1 bar is equal to, x1 bar is equal to means this x bar. This is x1 cos x2. Okay, and x bar 2 is equal to x1 sin x2. See, you may know, maybe it may be difficult for you to now agree to this kind of notation. But what is this? This is precisely what is x bar 1? X bar 1 is nothing but x. Okay, what is x1? X1 you can see that it is r. And what is cos x2? X2 is nothing but theta, so it is cos theta. Okay, similarly y is equal to r sin theta. So it is the same thing. This is the same thing. Okay, so but notation is a little, why we use this notation is there is some other purpose. Okay, so I have the inverse transformation for this. The inverse transformation. The inverse transformation. is. That means here what I am doing? I am doing the r theta coordinate system to xy coordinate system. Now from the xy coordinate system, if I want to go to the r theta coordinate system, then what is that? So that is x1 is equal to square root of x bar 1 whole square plus x bar 2 whole square. And x2, this is theta, is tan inverse x bar 2 by x bar 1. X bar 2 by x bar. So what is these two transformation? This is nothing but r is equal to square root of x square plus y square, and theta is equal to tan inverse y by x. But I have written it in a different fashion. So this is the meaning.
Sir,
So
what
this is
exactly
one-
are affine coordinates?
Eh?
What exactly are affine coordinates?
Fine coordinates. Look to the definition, what it says. It is quite clear. Dekho, this part. If xi bar are ordinary rectangular coordinates, okay, xi bar, ordinary rectangular, like x and y, rectangular coordinates. Then, what is that? X bar I kya hai? X bar I is this is x bar I is x bar I of functions of these rectangular coordinates, x1, x2, etc., xn. Then x bar i's are called the affine coordinates. X bar I. Okay, so here in this case, what are the affine coordinates? You can say in this case, rectangular coordinates कौन सा है?
x1,
बोलो
x2.
बोलो. x1, x2 नहीं है. x1 bar, x2 bar here, xy. Okay, and
Yes, sir.
so it is in this example, it is the reverse of this one. So affine coordinates are r and theta, because r and theta are functions of x and y. That way you have to take. This is affine coordinate. So this is the rectangular coordinates. The idea is clear to you?
Yes, sir.
Okay. So now, so we have seen one coordinate system, that is polar coordinate system. Now come to the second famous coordinate system, that is the cylindrical coordinates. So all these things you have studied in your geometry. Okay, so this is not a new thing, but the notation is something which is new. So next is cylindrical coordinates. Cylindrical coordinates. Okay, so I will draw the figure and then I will. Okay, first let me write like this. If if x bar 1, x bar 2, x bar 3. So this I denote by x, y, z, rectangular coordinates, and x1, x2, x3. So this I call it as r, theta, and z. Okay, with r greater than 0. With r greater than 0. Then we have the transformation formula. In cylindrical coordinates. Like this: x bar 1 is equal to x1 cos theta, cos x2. X bar 2 is equal to x1 sin theta. It's our natural thing. We will always go to theta. So this is x2, and x3 is equal to x3. Okay, so what is this actually? This is equivalent to x is equal to r cos theta. R cos theta. This means y is equal to r sin theta. And this is actually z is equal to z. So this is, you know, this is the cylindrical coordinates. Okay. So now one has to write what is the reverse transformation. Okay, the figure, and I will show you what is this transformation actually means with the help of the figure. So we will continue in the next class. Okay, so okay, thank you all. Any doubt? If you want to ask me any question, you can ask me now. Okay, if no questions, then we will meet tomorrow. Thank you all very much.
Thank you, sir.